When it says solve, isolate the variable, right? So I have to get the variable equal something. Most of the times, 90% of the time, it's going to be x, right? Okay, so number one. How do I do that? It would be nice. Would be nice if I had the same base, then I can exponentiate it, right? Well, let's see if we can make it the same base. Let's bring this down to the lowest base possible, 4. How can I rewrite 4? 2 squared, right? Did we do this? It feels like I did this. Okay, so 2 squared, I still have the exponent 3x, so I'm going to have to multiply those. Maybe I'm thinking of Abruzzo's class. And how can I change the 8 as a base 2? 7. What? Pay attention so you don't have to cheat next time. How can I change the... This is why we're a week behind. Okay, obviously I need a base 2, right? 2 to the cubed, right? But I still have to multiply the quantity x plus 1, right? And I say quantity because if you don't put it in parentheses, you are not going to distribute. And then we have that thing, well, not thing, the inverse, bless you, my son, the inverse property where it says if I take the log base 2 of each side, they cancel out. Right? Okay, so I get 2 times 3 is 6x equals, please don't forget to distribute, 3x plus 3, subtract 3x from both sides, I get 3x equal 3, divide by 3, I get x equal 1. All right, number 2. Let's see, I can rewrite 32 as 2 to the 5th? Yeah. 2 to the 5th. So I got 2 to the 5th times the quantity x minus 1. I did in my head 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 5. 5 2's I needed. Here, count on your fingers. 2 times 2 is 4, times 2 is 8, times 2 16, times 2 is 32. Okay, so 1, 2, 3, 4, 5. That's how I get 2 to the 5th. Okay, and then you don't really have to write log base 2 down because you know that these are going to cancel. So I got 4x equals, distribute to 5, 5x minus 5. You could either minus 4x add 5 or minus 5x. You get negative x equals negative 5, so x equals 5. Easy stuff, right? Couldn't be easier. How about number 4? Stop laughing. Can't have fun in math. I'm going to rewrite 216. Did I give you guys a chart with cubes and squares and quarter? Maybe it was last semester. I'll have to print some up for you. Okay. 216 is 6 cubed. Okay. So if I take the log base 6 of 6 to the 2x minus 7 equals 6 cubed, I could always take the log base 6 of each side. They cancel. I get x minus 7 equals 3. Add 7 to both sides. 2x equals 10. Do you guys mind if I don't write every solving step down? I think you're to the point where you know what I'm doing. Okay, parts 2 and 3. Again, we're still taking the log of both sides. Bless you. But this time, look what happens. I don't have the same thing on both sides. And there's no way there's no way I can make that 7 a base 2, right? So I'm going to bring in those properties that we learned and worked with for the past 2 or 3 days, right? These properties to get to that x in the exponent, okay? So I'm going to take the log base 2 of both sides because I want to get to that x. So I get, these cancel. So I get x equals log 2 of 7. And remember we learned the change of base formula yesterday? We don't have a log 2 key in our calculator. So what we did was we took the common log of the number divided by the common log of the base, or you could use the natural log. Put that in your calculators. Stop it, you two. God, you guys seem like you're married. Yeah, it would, but you guys act like it. And we're supposed to round to the 1,000, so it's 2.807. There's my answer. Easy peasy, right? Okay, number 6. In order for me to get to the x in the exponent, I'm going to have to get this term by itself. So I'm going to subtract 4 from both sides first. So I get 10 raised to the 2x minus 3 equals 17. This one I am going to take log base 10, right, the common log, because I have a base of 10. So I'm going to do log, common log, base 10, log, common log, base 10 of 17. These cancel. 2x minus 3 equals log base 10, common log of 17. Add 7 to both sides. Now, I'm going to go ahead and do that log of 17. Okay? Shh. I don't know where I got 7. It's because these guys are just bothering me and it's just throwing me off. It's all Jacob and Kylie's fault. Never blame myself. That's it's mine. That's what my wife says anyway. Never take accountability for things you do. Oh, I love you, honey. Log 17. 1.23, and I'm going to add 3 to it. So I got 4.230. So 2x equals 4.230. Divide both sides by 2. And I get 2.115. X equals 2.115. Did I screw that up for a lot of you to confuse? No? All right. How about number 7? I have to get this term by itself. I'm going to subtract 3. Bless you. So I get e to the 2x equals 8 minus 3 is 5. This time I have to use a natural log, right? Because I have e. ln of both sides. I get 2x equals, what's the ln of 5? ln of 5, 1.609. And then divide both sides by 2. I get x equal 0.80, round up, 5. Let's do a little harder one. How about number 11? I have base e. The term is by itself, so I'm just going to take the ln of both sides. ln cancels out base e, so I get 3x minus 1 equals the ln of 49. Shh. 3.892. Add 1 to both sides. So 3x equals 4.892. And then divide by 3. $1.631. You guys are going to have to do word problems. Yeah. Sorry. It's not my fault. Okay, you're cooking an Ethiopian. I'm sorry, you're cooking an licha, an Ethiopian stew. When you take it off the stove, its temperature is 212 degrees Fahrenheit. The room temperature is 70 degrees Fahrenheit, and the cooling rate of the stew is 0.046. How long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit? Use T. Use T equals T sub 0 or T naught minus T room temperature times E to the negative rate times time plus room temperature. You tell me. What would be a good application of something that needs to be cooled off? You're displacing heat. Machinery. How about brakes on your car? How about the heat that builds up in your engine? There's a lot of applications for dispersing heat. How about the space Challenger coming through the atmosphere? Whatever.
They didn't use the formula.
Probably had some student that was a smart ass, asking, "What are we ever going to use this for?" That was the guy that made the heat shield. That was the guy that made the heat shield for the Challenger.
It wasn't a heat shield that made it.
Okay. Shh. What are we looking for here? We are looking for the serving temp. So we're looking for capital T. Okay. We're looking for capital T. Its initial temperature. So this is T sub naught or T sub 0, right? T naught is 212. That's our initial T sub 0. 212 minus the room temperature is, should I use different colors so you guys know how to do this on the test? T sub r, 70 degrees. Times Euler's number minus the rate. What's the rate? Rate is 0.046. And plus room temperature. T sub r is 70 degrees, right? Are we looking for how long will it take? So we're looking for little t, aren't we? So we'll use little t, we'll use x for our little t. So we need to find x, right? We know what serving temperature is. It's 100 degrees. There we go. I know I was missing something. Okay, go ahead, solve it. What do you get? It's an Ethiopian. What do you get? It's an Ethiopian. I mean, I've got some real serious issues.
Your wife's a therapist.
I know. They're cooking Ethiopians. Probably go hungry.
No, that's how you solve it. Everybody that dies,
Did you ever? You'd still be hungry after eating an Ethiopian.
Yeah, because
there's get it, get it.
That's messed up.
Yeah, that's messed up.
It's a decent amount of skin, though.
Oh man, what'd you get? What'd you get? What'd you get? We're gonna eat Ethiopians. Okay, divide both sides by 142. Something doesn't seem right. I'll keep going. It's Ethiopian time. Okay, take the ln on both sides, right? So that the ln cancels my e. Are you with me? Are you with me? Are you with me? So the ln of 0.2113 equals negative, and I think I'll go up here, negative 1.5545, and then that's going to equal negative 0.046x. Are you with me? Are you with me? What'd you guys get? What'd you guys get? Divide both sides by negative 0.046. Negative 0.046. And it's going to take approximately 33.8 minutes for this Ethiopian to cool off. Yep. Or 34 minutes. So did you guys get homework sheets? Yes.
Yeah. Yeah.
Should we do a couple of your homework problems?
She only sees like the little parts to show
Questions, comments, concerns? Actually, that's the right answer, so I did it right for a change. Let's do some examples on your homework, A. Let's do this one first. Okay, I got to take the log base 20, base 20 to both sides, so that these cancel out. I get m equals log 27, change base, log 27 over log 20. By the way, you could use a natural log too. 1.1001, 10 thousandths we need. Number 2. See, I'm going to take the natural log, both sides. Oh, well, no, I can't. Can't do that. Never mind. So, I have Ooh. We didn't use a property last on the homework sheet, did we? Okay, so I have the ln of 11 raised to the n. I'm going to use x minus 4 equals the ln of 44. Okay? Hey, this is an important part. This wasn't on your notes. Shh. Shh. This wasn't on your notes. Okay? I need to bring that out, right? Because that's my exponent. So I have x minus 4 times the ln of 11 equals the ln of 44. Divide both sides by ln of 11, right? Divide by ln of 11. So I get x minus 4 equals, put this in your calculators, a curse of x in a minute. ln of 44 divided by ln of 11, 1.5781. And then I'm going to add 4 to both sides. Okay, so x is going to equal 5.578. Let's see if we can do another one here where that happens. Let's try number 7. I don't know if it does or not. Subtract 10 from each side. I get e to the 1.2. I'm going to use x again. I don't like using these other ones. Plus 8 equals 50. Nope, this is going to be a straight ln problem, log problem. So I get 1.2 x plus 8 equals ln of 50. 3.9120. Subtract 8 from both sides. So 1.2x equals negative 4.087, or actually 80, round up. Divide by 1.2. And I get x equal negative 5.288. Should we do some on your other worksheet? Let's look at your other sheet. Now, remember the other inverse property we had? Where if we had the same log, same base on both sides, it just cancel out. That was my other property. So I have 3b plus 5 equal b plus 7. 2b plus 5 equals 7. Subtract b from each side. Subtract 5 from each side. I get 2b equal 2. Divide by 2. So b equal 1. How about number 5? Number 5, you have to, I only have log on one side and the number on the other, so you're going to have to exponentiate, right? So I'm going to use this base, exponentiate to 5, so that these cancel. I get my b minus 9 equals 5 to the negative 2. 5 to the negative 2 is what? Well, 1 over 5 squared, which is 25. Right? Right? Shh. Okay, add 9 to both sides. What? Did I? Oh, okay, well, you got it again today. It's there today. 9 plus 1 divided by 25. Enter. Math. Enter. Enter. 226 over 25. So we're kind of using all these properties, so we have like 5 properties. We got to change the base formula. We got exponentiate. So we got a lot of things going on with logarithms, right? Maybe I should make you a formula sheet for it, huh? Would that help? And you need x squareds, cubes, and fourths. Right, number 7. We could do number 7. Subtract 2 from both sides. So I get log base 5 of x plus 3. equals negative 3.
You made these so much better.
Okay.
I thought it was
Exponentiate. Shh, 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 shh. Exponentiate. 5, 5. So I get x plus 3 equals 5 to the negative 3. Huh? Should be a positive. Thank you. That makes more sense. Thank you. Subtract 3. So x equals 125 minus 3. So x equals 122. Thank you. That saved me a lot of work.
No. I'm not arguing.
All right, this is looks like the video held. So